Pythagorean theorem states if you have a right triangle, then the sum of the squares of the length of the legs of the right triangle is equal to the square of the hypotenuse. That's exactly what the Pythagorean theorem actually says. If a triangle is a right triangle, then the sum of the squares of the length of the legs is equal to the square of the hypotenuse. We have condensed it to say A and B are legs of a right triangle. C is the hypotenuse. So if you have a right triangle, then A squared plus B squared equals C squared. Okay, but it's really the sum of the squares of the length of the legs is equal to the square of the hypotenuse. Now there's also a converse theorem. And you'll learn in geometry that a converse theorem reverses the order of the original theorem. So the converse of the Pythagorean theorem says if you have a triangle such that the sum of the squares of the length of the legs is equal to the square of the hypotenuse, then the triangle is a right triangle. So the original theorem says if you have a right triangle, then A squared plus B squared equals C squared. And the converse theorem says if you have a triangle such that A squared plus B squared equals C squared, then the triangle is a right triangle. So you can prove different things based on the actual theorem and the converse theorem. Okay? So those are those. We got a right triangle. A triangle that has a 90-degree angle in it is called a right triangle. Is it possible for a triangle to have more than one 90-degree angle in it? No. Do y'all remember what all the angle measures have to add up to be in a triangle? 180. So if your triangle has how many angles? 3. And 2 of them equal 180, you don't have room to have a third angle, right? So you can only have at least one 90-degree angle. You can only have one 90-degree angle in a triangle. Can you have, same token, can you have more than one obtuse angle in a triangle? What does obtuse mean? Larger than 90 for the same reason. Okay? You can't have anything larger than 90 in two angles that are larger than 90. So let's talk about legs and hypotenuses. All right? So your legs are your two sides of the triangle that form to make the 90-degree angle. So if it touches the 90-degree angle, it's a leg. All right? Now the other side of a right triangle is called the what? Hypotenuse. Now that is the one across from the 90-degree angle. It does not touch the 90-degree angle. Okay, so if it touches the 90-degree angle, it's a leg. If it's across from it and does not touch it, it's the hypotenuse. What's something else we know about a hypotenuse of a right triangle? It's the longest length. It's the longest side. Very good. All right, so A is a leg, B is a leg of a right triangle, C is the hypotenuse. So our condensed version of the Pythagorean theorem is A squared plus B squared equals C squared. You need to memorize that. Next week, y'all remember in chapter 10 how we had a little mini quiz on the little B sheet of paper? We're going to do the same thing for these formulas that we're going to learn in the next few days. Number 1 will say write the Pythagorean theorem, and you will write A squared plus B squared equals C squared. Okay? So you need to memorize that if you haven't already memorized that. So what we're going to do to start with is we are going to be given a right triangle and 2 of the lengths of some sides of the right triangle, and we have to find the missing side using the Pythagorean theorem, A squared plus B squared equals C squared. Okay? So it's basically plugging in and solving an equation. So we're going to start with just writing A squared plus B squared equals C squared. And we're going to fill in the ones we know. Now, which one did they not give us? C. So we're finding C, which is the what? Hypotenuse. So we're finding the hypotenuse given the 2 legs. So A is what number? 8. So I plug an 8 in for A. B is what number? 15. Equals, and we don't know C, so we leave C alone. So we know 8 squared plus 15 squared has to equal C squared. So we're going to solve that for C. So we're going to know our squares. What's 8 squared? 16. 64 plus what's 15 squared? 225 equals c squared. And then we need to add on that left-hand side. So what's 64 plus 225? 289 equals c squared, not c. So how do we get it equal to just plain c? Right. Remember, a square root takes care of canceling out a square. So we got to do this to both sides. So square root both sides. And that cancels my radical and leaves me with just c on the right-hand side. So what is the square root of 289? 17. So my hypotenuse is 17. Also, our answer should make sense. If we were finding the hypotenuse, it should be the longest of all three sides, right? Is 17 longer than 8 and 15? Yeah, so we kind of double check that sometimes if you have all numbers and no radicals, just to make sure that side is actually the longest side if you're finding C. Okay? All right, we're just going to practice doing this a few more times with different letters. On problem B, which one's missing?
C.
C again. So we're going to find C again. I'm going to plug into a squared plus b squared equals c squared. What goes in for a?
7.
7. So 7 squared, what goes in for b?
24.
And we don't know c, so leave c alone. C squared. What is 7 squared?
49.
Plus what's 24 squared?
576.
Equals c squared. Then what do? We add. What's 49 plus 576?
625.
Nice. And do I leave it like that, or what do I have to do? Square root of both sides. And what's the square root of 625? 25 equals C. And again, is that the longest side? It is. Any questions so far? All right, so far we have just found C. Which one is missing on the next problem? A is missing. So I have a squared plus b squared equals c squared. And I was told last block that my b's and sixes look alike, so I'm apologizing in advance. So I'm plugging in my 6 for b and my 7 for c. I don't know a, so I'm going to leave a squared alone. What is 6 squared? 36 equals what 7 squared? 49. And then how do I solve that for a? So a squared equals what? 13. And then what do I do to both sides? Square root. And the a squared and the square and the radical cancel out everything and leave you just with the a. Now, guys, this is chapter 11, and we have learned how to simplify radicals. So we are not going to type these in and get a decimal. We're not going to do it. So we're going to simplify radical 13 if possible. So remember, to simplify a radical, you look to see what is the largest square number that goes into 13. Does this one have one besides 1? No, because 13 is what kind of special number? It's prime. So the only numbers that even go into 13 are 1 in itself. So we leave it radical 13. Do not put that in the calculator and say that is 3 point something. I don't care. I want you to leave it radical 13. That is the exact answer. Okay? So we put it in the calculator, get a decimal. That's a rounded answer. All right, any questions about that? Look at D, please. A is 4 and C is 9. Which one's missing? B. So we're going to plug that into a squared plus b squared equals c squared. What goes in for A? 4 plus what goes in for B? Oh, it's 4 squared, sorry. We don't know B, so leave it b squared. Equals what C?
9.
So 9 squared. And then I'll square my numbers. What's 4 squared? 16 plus b squared equals what's 9 squared? 81. And now what do? Subtract 16 on each side. So b squared equals what's 81 minus 16? 65. And how do I get it just b by itself? Square root. Cancel, cancel. What's the largest square that goes into 65, or is there anyone besides 1? Well, 65 is 13 times 5, and I don't really think there's anything besides 1 that goes into 65 besides those numbers, right? So I think we're going to leave it b equals radical 65. Any questions about that? All right, problem E is a little different because one of the side lengths is a radical, and this is actually really easy when you have one like that. So we're going to say a squared plus b squared equals c squared. Which one are we finding, a, b, or c?
C.
C again, the hypotenuse. So when we say radical 12 squared, what do you think is going to happen? Yeah, the square and the radical is going to cancel out. So that's actually no problem if you have a radical. So that's just going to be plain old 12. Because radical 12 squared, the square and the radical cancel out. Plus what's 6 squared? 36 equals c squared. And then we're going to add 12 plus 36 and get what? Equals c squared. And then we do what to both sides? Square root. So the c squared and radical cancel out and leave you with c. What's the largest square that goes into 48? 4 is a square that goes into 48, but it's not the largest, is it? 16. So it's 16 times 3 is 48. And what's the square root of 16? 4. So this one is 4 radical 3. So simplify your radicals if you get something that's not a perfect square. Is that terrible? That's really as worst it gets. All right. So I want you guys to try this one. Find the missing side. So do it and then get your answer checked with somebody else, please. So which one's missing, y'all?
B.
B is missing. So what goes in for A? 11 squared plus B squared equals 61 squared. What's 11 squared?
121.
Plus B squared equals what's 61 squared?
3,721.
And then how do you solve for B? Subtract 121 on both sides. So B squared equals 3,600. And then what do you do to solve it for just plain B? Square root. Is that a perfect square? So B equals what? 60. Raise your hand if you got B equals 60. Isn't that nice? All right, good job. All right, so that's using the actual Pythagorean theorem. Now we're going to use the converse of the Pythagorean theorem that says if it works out to where the sum of the squares of a triangle equal the square of the hypotenuse, then you have a right triangle. So if a squared plus b squared is true for a triangle, then it's a right triangle. So we're going to take these three sides and determine if it's a right triangle. So how do you think we're going to do that?
You put the biggest one in for C.
Yes, the biggest one has to go for C, right? Bless you, because the hypotenuse is always going to be the longest side. Does it matter which one you plug for A or B?
No.
No, they could be interchanged, but C has to be the longest side. Now, most of the times these are written in numerical order for you, but it's always safe to double check because sometimes they mix up the order. Does that make sense? So always make sure C will be your longest side. So if A squared plus B squared equals C squared is true, then yes, you have a right triangle. If it does not work out to be true, then no, you don't have a right triangle. All right? So it don't matter, like we said, which one's A and B. We just know 17 has to be the C. So 8 squared plus 15 squared equals 17 squared. What is 8 squared?
64.
Plus, what's 15 squared?
225.
And what's 17 squared?
289.
So if I add 64 plus 225, do I get 289?
Yes.
Yes. So that is true. So yes, this one is a right triangle. Does that make sense what we're doing? If the a squared plus b squared equals c squared is true for those numbers, for those side lengths, then yes, you do have a right triangle. And if it's not true, then no, you don't have a right triangle. It is. So this is supposed to be problem G. I guess I erased the letter. What has to be C on problem G? 9 has to be your C. So I'm having 5 squared plus 8 squared. I'm going to see if that equals 9 squared. What is 5 squared? 25. Plus what's 8 squared? Equals what's 9 squared? Is that true? No, I'm getting 89. Does 89 equal 81? No. So I like to go back and slash my equal signs because I don't like to leave untrue things on my paper. So no, this one is not a right triangle. I don't want bad math on my paper. All right, so any questions about those?
Will it be okay even if we don't go through and slideshow?
It's technically incorrect if you say some 89 equals 81 and it's not. I'll try not to look at it because it'll hurt my eyes and make me cry. Y'all try these two. See if these are right triangles or not. And I know these are easy to just type in your calculator and see, but I want something on paper. I ain't saying you have to show every step on paper, but show me something on paper. So test it out, then tell me yes or no if it's the right triangle. Check them with a neighbor when you get done. All right, y'all help me out. What's 7 squared?
49.
What's 11 squared?
121.
What's 13 squared?
169.
Is that true or false?
False.
No, because I am getting like 170, right? So is this one a right triangle?
No.
No. Raise your hand if you got no for number 1. Check no. You are not a right triangle.
I like that.
All right. So help me with the next one. What's 15 squared, y'all?
225.
Why did I write that 5 up like an exponent? Plus, what's 36 squared?
1,296.
What's 39 squared?
1,521.
21? Is that true?
Yes.
Yes. So raise your hand if you got yes, that one is a right triangle. Any questions about those? All right, so that is Pythagorean theorem and the Pythagorean converse theorem. Have a good day.